So in today's lesson, we shall be looking at the classification of second-order nonlinear PDE. In our previous lesson, we discussed about the classification of first-order nonlinear PDE. But in today's lesson, we shall be looking at what? The second order. So without wasting much time, let's look at what this second order means. The first order and then the second order are almost the same, but there are slightly difference amongst them, and that's what we are going to fish out to enable us to classify this second order nonlinear PDEs under the semi, the quasar, and then the fully nonlinear PDE. So we are starting with the semi-linear PDE. So when do we say that a second order nonlinear PDE is a semi-linear PDE? So the first one is, it is linear in the highest derivatives. It means that the highest derivatives within that equation are all linear. It is linear with respect to the highest derivative. And as I said in our previous lesson, to classify nonlinear PDEs under semi-linear, quasi-linear, and then fully nonlinear, our concentration is going to be on the highest derivatives. And since we are talking about a second order, our highest derivative is going to be uxx, uxy, and then uyy. So our focus is going to be on these three, whether they are linear or non-linear. So with the semi, we are saying that it is linear with respect to the highest derivative. So it means that within that equation, we should have the uxx, the uxy, and the uyy being all linear. Our focus is on the highest derivative. Now, once the highest derivatives are linear, then we move on to the second point. It says that the non-linearity is on the lower order derivatives. The non-linearity is on the lower order derivatives. So with this, our lower order derivatives, we shall be looking at the u, the ux, and then the uy. If you could remember, when we were dealing with the first order nonlinear PDE under the semi-linear, we said that the non-linearity is on the u, only the dependent variable u, only this one. But with the second order, the non-linearity is going to be on the u, the ux, and then the uy. That is the difference between the first order semi-linear and the second order semi-linear PDE. So if you understand this, let's look at the examples here. So we have some 5 examples that we are going to go through. All of these are nonlinear PDE. So we have uxx plus uyy is equal to sine ux. So you can see that these are our highest derivatives. So the highest derivatives are uxx and then uyy. Are they linear? So you can see that these two highest derivatives are linear. Then you move on to the lower order derivatives, that is the ux and then uy. And then we check to see if they are also linear or non-linear. So you can see that the lower order derivatives, so you can see that we have a transcendental function on the lower order derivative, that is this one. So the non-linearity is on the lower order, and if that happens, that type of non-linear PDE is what a semi-linear PDE because of what this. So this becomes a semi-linear PDE because the non-linearity is on the lower order, which is what the ux, the uy, and it can also be on the u as well. Now let's look at the next one. We have our highest derivatives. As I said, with the classification of non-linear PDE, our focus is going to be on the highest derivatives. So first we have to identify our highest derivatives. So we have the ux's and the uyy. These are our highest derivatives, and they are linear. If they are linear, they move on to point 2. The non-linearity is on the lower order derivatives such as u, ux, and then uy. So we have to look for u, ux, and then uy. So you can see that we have u here, and this u, we have a transcendental function, and this transcendental function is on the u, and this makes the PDE a nonlinear PDE. And the type of nonlinear PDE is what? A semi-linear PDE, because the non-linearity is on the U. So this becomes what? A semi. As easy as A, B, C, D. Let's look at the third one. You can always pause the video and then you try your answer, and then before you cross-check your answer with mine. So first, we have to look for our highest derivatives, and these are our highest derivatives. Are they linear? They are linear. If they are linear, then we move on to the lower order derivatives such as the ux, the uy, and the u as well. So we have to look for these. Now you can see that we have u here. This u is linear. The dependent variable is linear. But when you look at this, it is not linear because we have a degree of 3. This degree 3 makes the PDE non-linear. And the type of non-linear is what? A semi-linear. Because the non-linearity is on the U. Very, very easy and then simple. Let's look at Ivan. So first we have to search for our highest derivatives to check to see if they are linear. So this is one of our highest derivatives. It is linear. We also have this. It is also linear. We also have this one as well. It is also linear. The non-linearity is on the lower order derivative. So we have to look for this, either this or that. So you can see that we have a lower order derivatives and we have a degree 2 here. This degree 2 on the lower order derivatives makes the PDE a nonlinear PDE. And the type of nonlinear PDE is what? A semi-linear PDE. So this one is also a semi because the non-linearity is on the lower order derivatives. And that is what this. Now let's look at the last one. What do you think is going to be? Is it going to be a semi? Let's check it. So we are first going to identify our highest derivatives. That is USS. It is linear. URY is also linear. So these are our highest derivatives. Since they are linear, we move on to the lower order derivatives. So you can see that we have UX, which is the same thing here, the lower order derivatives. We have UX here. And we can see that we have a transcendental function length on the lower order derivatives. And if that happens, this makes the PDE nonlinear. And the type of nonlinear is what? A semi-linear. Because the non-linearity is on the lower order derivative. Very, very easy and then simple. So in summary, we can say that for a second order nonlinear PDE to be a semi-linear PDE, then it must be linear with respect to the highest derivatives. That is this, and that must be linear. And then the non-linearity must be on the lower order derivatives. So we have to search for this, and that. Very, very easy and then simple. Let's look at the other classification. So we are looking at the next one, which is the quasi-linear PDE. The quasi-linear PDE. When do we say that a second order nonlinear PDE is a quasi-linear PDE? It becomes a quasi if these two conditions are met. So the first one says that it is linear with respect to the highest derivatives. It means that the higher derivatives within that equation must, or all of them should be linear, must be linear. And then since we are looking at the second order, our highest derivatives are going to be the USS, UXY, and then UYY. Our focus should be on this. And then the second condition that differentiates it from the semi is the non-linearity is as a result of the product of the highest order derivatives and then the lower order derivatives. So this we shall be looking at the product of the highest derivatives and then the lower order derivatives. And when we talk about lower order derivatives, we shall be looking at the ux, and then uy. And the product of the highest and then the lowest, we shall be looking at. Let's take it that you have the lower order derivatives such as u or the dependent variable u multiplying the highest derivatives, let's say ux's. If this happens, then we can see that that nonlinear PDE is a quasi-linear PDE because we have a lower order derivative multiplying a higher order derivative. Now we can have the partial derivative with respect to x multiplying any of the highest derivatives such as uyy. And when this happens, that PDE becomes a quasi-linear PDE. So with the quasi, we shall be looking at the product of any of these lower order derivatives multiplying the higher order derivative. Very, very easy and then simple. So as I said, with the classification of nonlinear PDs into the semi-quasi and then fully, our concentration should be on the highest derivatives. Keep that in mind. So let's look at this example to see if they are actually quasi-linear or not. So looking at the first equation, you can see that we have UXS, UYY. So we ask ourselves to see if they are linear or not. So you can see that this one, the UXS is linear. You can see that the UYY is also linear. Then we move on to see if we can find a highest order derivative multiplying a lower order derivative. So you can see that we have this, a lower order UY multiplying the highest derivative. If this happens, then that PD becomes what? A quasi. It becomes what? A quasi-linear PD, because we have a lower order derivative multiplying the highest order derivative or the highest derivative within that equation. Now let's look at the next equation. So as I said, our concentration is on the highest derivative. So our highest derivative in these PDEs, we have this one, a second order PDE. So they have the highest derivative, a second order derivative, and then we have a highest derivative. You can see that these two are all linear. If they are linear, we also have this, this is also a second order. We have one of the highest derivatives. So we have this, and that. All of them are linear. And I believe you can see that. Now, once they are linear, then we try and see if we can find a lower order multiplying any of these highest derivatives. Now, I can see that we have US, which is a lower order derivative. When we expand this is going to give us what? US and then USX. This will give us USS when you expand the brackets. So when this happens, a lower order multiplying the highest derivative gives us what? A quasi. So this becomes a quasi-PD, quasi-linear PD, a quasi-linear PD. Then let's look at the third one. You can pause the video and then check to see if you can get the correct answer. So let's first identify our highest derivatives. We have the USS as 1. We also have this. Then we check to see if they are linear. So USS is linear, UYY is also linear. Then after that, we check to see if we can find any of these multiplying any of the highest derivatives. Now you can see that we have a lower order UX multiplying the highest derivative, because when we expand this bracket, we are going to get U squared X multiplying UXS. And this makes the PD a quasi. So identification of quasi are very, very easy to see. Just a lower order multiplying a highest order, and then you are good to go. So let's look at the last one. So first we are going to identify our highest derivatives, and this is UXY. So this is our highest derivative, and you can see that this highest derivative is multiplying a lower order derivative or the dependent variable. And whenever you see this, that PD becomes what? A quasi-linear PD. So we have quasi. Very, very easy and then simple. Let's look at the last one and then away. So we are looking at the last one. That's the fully nonlinear second order PD, fully nonlinear. So the fully nonlinear, what we are saying is that the non-linearity, what makes the PD nonlinear, is on the highest derivative. What makes the PD nonlinear is what? On the highest derivative. So it means that within that PD, we shall be seeing something of this form: U squared SX, length of YY, length of UYY, and then U cube XY. All of this makes the PD a nonlinear, and then the non-linearity is on the highest derivative, since we are talking about a second order PD. So that is the fully nonlinear. It is very, very easy to identify. So as I said, with the classification, our focus should be on what? The highest derivative. So if the highest derivative is nonlinear, then that PDE becomes what? A fully nonlinear PDE. So we have an example here that we want to look at to see if they are actually fully nonlinear or not. So the first one, you can see that we have uxs multiplying uyy, and then we have u squared yy. So as I said, the first thing that you are supposed to do is to identify your highest derivative within that equation. So from the equation, our highest derivative, we have this and that. We also have this and that. And then we are saying that the non-linearity is on the highest derivative. And you can see that we have two highest derivatives multiplying. And whenever you have two highest derivatives multiplying, it becomes what? A nonlinear PDE. And the type of nonlinear PDE is what? A fully nonlinear PDE, because the nonlinearity is on the highest derivative. If we're looking at this, this is also the highest derivative, one of them, and we have the degree 2. This degree 2 makes the PDE nonlinear, and the type of nonlinear is what? Fully nonlinear, because the non-linearity is on the highest derivative. Now let's look at this one. So first we have to identify our highest derivatives. We have uxs and then uyy. Then you ask yourself, are they linear? No, they are not linear, because we have the degree 2. This makes it nonlinear. Degree 2, this makes it nonlinear. And the non-linearity is on the highest derivative, so it makes this PDE a fully nonlinear PDE, fully nonlinear. There is this one to the last one. You can see that we have a transcendental function on the highest derivative. We have the highest derivative. This one is linear, but with this one it is not, because this transcendental function on the highest derivative makes it a nonlinear. And the type of nonlinear is what? Fully nonlinear, because the non-linearity is on the highest derivative. Very, very easy and then simple. So we want to classify these PDEs under linear, fully nonlinear, semi-linear, and then quasi-linear. So let's start with the first one. So we have u multiplying uxy plus uxuy is equal to y exponent xy. So as I said, our concentration is going to be on the highest derivative. Since all of these are second order PDEs, our highest derivative is going to be what? The uxx, the uxy, and then what? Uyy. So our concentration is going to be on these three. So let's identify our highest derivative from the first one. So you can see that our highest derivative is uxy. And you can see that the uxy, which is, we can see that the highest derivative is multiplied or being multiplied by a lower order or a dependent variable. And if this happens, it makes the PDE a quasi-linear PDE. So this one is quasi. We have quasi because we have the dependent variable multiplying the highest derivative within that equation. So it becomes a quasi. Now let's look at this one. We are first going to identify our highest derivatives. So we have this to be one of our highest derivatives. This is also one of our highest derivatives. Then we look to see if we can have the highest derivative being multiplied by a lower order derivative. So you can see that we have a lower order derivative multiplying a higher order derivative. And this makes the PDE what? A quasi-linear PDE. So we have quasi. So this one too becomes what? A quasi. Quasi are very easy to identify. Now let's look at the third one. So we're first going to identify our highest derivatives. We have this is one of them. This is also one of them. This is also one of them. Are they linear? You can see that all of them are linear. Good. If they are linear, then we move on to the lower order derivatives such as the u, the ux, and then the uy to see if they are linear or not. So you can see that we have one of the lower order ux. It is not linear because we have degree 2. So this degree 2 makes it non-linear. We also have a lower order with degree 2, and then we have the dependent variable with what? Degree 3. So this makes the PDE a non-linear PDE. And since the non-linearity is on the lower order derivatives, this PDE becomes what? A semi-linear PDE. So the third one is semi. Now let's look at the fourth one. So the fourth one, we have our highest derivative with uzz, and then we have uxy, and then we have uxs. We can see that all of them are linear. If they are linear, then we move on to the lower order derivatives. So we have ux, it is also linear. So it means that it is linear with respect to the higher derivatives and then the lower order derivatives. And so this becomes a linear PDE. It becomes what? A linear PDE. So let's look at the last one. So we have our higher derivative here. We have one of them here. This one is linear. But with this one, we have a transcendental function on one of the higher derivatives. And this makes the PDE a nonlinear PDE. And since the non-linearity is on the higher derivative, which is this, it makes this PDE a fully nonlinear PDE. Very, very easy and then simple. See you tomorrow. Bye bye.